because number 3 is a very challenging question. Okay, first off, it is going to require a logarithmic regression. We already gone through and stated that. Be really careful. You're not going to use the logistic. You're going to use the natural log. We already talked about that. Okay. So it has 3 parts. It says write the logarithmic regression, rounding the coefficients to the nearest 10,000th. So I'd like you to go in, clear out your lists L1 and L2, enter this data from the X column in L1, this Y column in L2. Okay, so we're going to call this L1, call this L2, and we're going to tell what we did. We entered the data, and then we're going to do a natural log regression, a logarithmic regression. Okay, once you've done that, I'd like you to play the recording. Okay, so hopefully at this point you have gotten a screen that looked something like this. We're going to disregard the correlation coefficient, the R value here. It's only really relevant when we have a linear regression. But nonetheless, we have a value of A and a value of B. So that's what came out on our paper. We're going to write that down, state what A and B are. And then I want you to sub them in to the model, so like the template here, to write your equation. Right, so hopefully you have an equation that looks like this. I'm just subbing in the numbers for A, for B. I've got question number 1 answered, or part A, I guess you would say, of question 3. Next question. This one says, using this equation, we're going to figure out when the wind speed would be 50 miles per hour. So obviously that's off our chart. That's called extrapolating, going beyond the data to make a prediction. What we had done earlier with the blocks from the beach was called interpolating, inter meaning between 2 data. This is extrapolating, extra meaning outside of. Okay, so wind speed is 50. So I pretty much just need to figure out, well, is that the X or the Y, and make a substitution. So hopefully you can figure out, well, that's the X. So this is going to be an easy question. We're just going to sub in with our calculator 50 for X. Let our calculator crank that out. Comes out to be about negative 16 degrees Fahrenheit. So we have to look and see if that makes any sense. Well, yeah, 50 would be way down here. Yeah, I can see how that could be negative 16. That's reasonable for me. Last question. In this question, we're considering a wind chill factor is 0. What would be the wind speed to the nearest mile? Okay, so wind chill factor of 0, that would be a Y value according to these column headings. 0 would fit in here between 1 and negative 5. So I'm guessing it's going to be really close to, like, I don't know, 6, 7 miles an hour, something like that. So we need to sub in 0 for the Y value and then do some math. So again, this is an interpolation question. It's in between. So I sub in 0 for the Y. Got to solve this logarithmic equation. So this is a good review of how we solve log equations. First, we want to get the natural log of X all by itself. So we can't subtract these 2 numbers. They're not like terms. This is the coefficient of this variable expression. I have to subtract the 13, and then I have to divide by the negative 7 number, and I get the natural log all by itself. And now we're kind of stuck. If you remember, and by the way, leave lots of decimal places. We're going to be rounding this thing off to the nearest mile, but I want you to leave lots of decimal places with log equations. We want to solve a log equation. We want to put it in exponential form, so we need to know what is the base. Well, we didn't see the base. Remember, it's an implied base of e. So rewrite natural log of x as log base e of x, and now put this into exponential form. Remember, log base e of x. You know what the base is. The log is the exponent. So there's our exponential form. E to that number equals x. Pop it in your calculator. 6 miles an hour. It wasn't that what we predicted it would be, between around 6 or 7, something like that. The next question I'm not going to do with you, but I do want to give you a heads up on this one. Number 4 gives you some particular information about how to enter your data in the calculator. So you're not simply going to enter in this into L1 and this into L2. You have to read sometimes. This is a power regression, and it gives you information about how to enter the data. It says if x equals 1 represents the year 2000, that means put into L1 1, 2, and 3 to represent the years 2000 and the subsequent years. You're going to go through, do a power regression, and get a function here. And then it says, using this equation, find the estimated number of new cases for the year 2007. So you're going to have to think about, was that an X or a Y? And then how do I convert that into these values? In other words, if the year 2002 is a 3, and the year 2001 is a 2, what therefore would be the year 2007? Okay, I'm sure you can figure that out. Last thing I want to review with you is a little bit about the correlation coefficient. Okay, let's skip ahead to number 9. Question number 9 says, if I have a linear regression involving a student's attendance and his degree of success in school, what would be the possible correlation coefficient for this data? Well, we don't have the data, but all we have is this equation. So looking over my choices, I've got some choices for R. Well, the way to reason about this is an equation. I don't know how well it fits the data, but I do know it has a positive slope. So that pretty much rules out some of my choices here. You know, like the one that has 0, I can pretty much rule that out. The one that has negative doesn't make any sense. The one that says it's between -1 and 0 doesn't make any sense. So pretty much the only one that makes any sense at all is the one that's between 0 and 1. And then finally, the last question has a relationship between a woman's shoe size and the length of a woman's foot. Well, just kind of looking at this, what could be the possible relationship here? Of course, you could put this data in your calculator and actually compute it, but let's not even do that. Let's just look at the trend. As the shoe size goes up, as X increases, Y also increases. So I can definitely say it's not a -1 and it's down to 0. So the question is it a perfect fit or is it really a crummy positive fit? And as we can see, as X goes up by 1, Y goes up by 0.25 each time. So it seems like there is a perfect fit here, and the answer is choice 1. Thanks for watching.